Hi friends, welcome to follow up. Let's have a look at problem 2542, maximum subsequence score. In this video, I'm going to explain a solution based on the use of min heap. So here we are given two zero-indexed integer arrays called nums1 and nums2 of equal length, and the length is m. And also we are given a positive integer key. We must choose a subsequence of indices from nums1 of length k, and then we are going to compute a score. So the score is computed as follows. So this is the indices list, and then we choose the corresponding elements from both nums1 and nums2. Then the score is defined as the sum of the corresponding elements in nums1 times the mean of the corresponding elements and those indices. So we want to find the maximum possible score. So here a subsequence is to be distinguished with a subarray. So a subsequence isn't contiguous in general. So here we have two examples. The second example actually is very special because here k is 1, right? So we just need to find the maximum corresponding product at each index, right? So here at index 2, so we have 3 times 10, that is 30. So the example 1 return is 30. So in example 1, so k is 3, the output is 12. Here is an explanation. But here it lists all the possible four subsequences scores. We are going to use this example to fix the idea later. So before we do that, let's look at the constraints. First, the length is given by n. So and n is bounded above by 10 to the power 5. So 10 to the power 5 is basically an upper bound for the problem size here. And we know that also we are assuming elements in nums1 or nums2 are non-negative and bounded above by 10 to the power 5. So k is less than or equal to n and greater than or equal to 1. So this is for consistency. So with that said, basically we can do the analysis. So I'm going to use example 1 to fix the idea. So here we need to we can sort the corresponding list. For example, we can sort nums2, but in this time we need to sort correspondingly for nums1 because we want their indices to be 1 correspondence. So here if we zip the two together and the nums1 and nums2 and then sort, so here we can sort either in reverse order or in increasing order. That does not matter. The logic is the same. But here I sort it using decreasing order. So after we sort nums2 in decreasing order, so we have 4, 3, 2, 1. So the 4 corresponding to the last index 3. So the index 3 element in nums1 is 2. So we have 2 here. So 3 corresponding to index 2. So the index 2 in nums1 is also 3. So we have 3. So we can interpret 1 and 3, right? So this is num2 and this is num1. So first we're going to examine if we fixed a mean. So what's the maximum sum we can find? And then we do the comparison. So in this example, k is 3, right? So if we choose the first 3 elements, we can make sure that the mean is 2, right? And in this case, we want to find the corresponding element is 2, 3, 1, right? So the sum is 6 and the mean is 2, so the corresponding score is 12. And then we're going to look at this one. So if the mean is 1, right? So we need to include this 3 because this 3 is corresponding element. So this is the 1 element. So we need to choose another 2 element from the previous, right? Because once we choose this 1 in nums2, the mean is for sure. If we look at to the left, it will be 1. And we need to choose 2 larger ones, right? So here is 3 elements. So here is 1. We need to pop 1 from the previous 3 chosen elements. In other words, we need to pop this 1. So then we get 2, 3, 3. In other words, we choose 2, 3, 3 in nums 1, and correspondingly we choose 4, 3, 1 in nums 2. So the mean is 1, and the sum is 2 plus 3 plus 3, that is 8. So the corresponding score is 1 times 8, that is 8. But in this case, we need to return 12 for this problem, because it's the maximum. So once we notice this pattern, we know that after sort, so we can do sliding window. And each time we look at a new element, right? So this new element will correspond, the element in nums 2 will correspond to the mean in the key value chosen from nums 2. And then we want to include the current element, but we need to pop from the previous chosen key element the smallest one. This way, we use a running sum to minus that one smallest element, and then we plus the current element. We're going to have the maximal sum, and then we multiply this minimum. Then we compare with the previous state of the score, and then we return the largest one. So this is the overall logic. So in order to continuously pop out smallest element from the previous key chosen element, so we can resort to heap. So this is natural for now. So with that done, we are ready to do the coding. So for doing the coding, so I'm going to introduce a zip. So this will be a zip, basically nums1, nums1, nums2. So this gives us an iterable of tuples, and then we can do the sort, right? So here, if we make it a list, so we can directly resort to the list sorting method, right? So zipped, we can do sort in place. So here we can do sort in a reverse order, or you can specify a key as you like. And then what we are going to do is we are going to initialize a heap. So here I'm using h for that. And then I'm going to introduce a running variable that is total, originally 0, right? Then we first get the first key element. So this corresponding to the largest minimum we can choose. For this example, that is 2, right? So let's do this. So for I in range k, right? So this iterate k times. So we get the number 2, number 1 equals zipped I, right? And then what we are going to do, we are going to increment the total by n1, because we want to use sum in nums1, and we use minimum in nums2, right? And then in this case, so we're going to heap, let's see, this currently a list, so we are going to append the element n1. So after we exit this while loop, this for loop, we are going to have a total that is the current maximum sum, and also we know we have already also stored the previous key chosen elements, right? So this is one task. Next, we want to make this each a heap. So basically, we are going to do heapify it. And then currently, let's introduce a running variable that is the result of score. Let's use score as maybe a good one. So we have a total times the minimum. The minimum will be the case value in the zipped corresponding to nums2. So that is zipped k minus 1. This is the index, right? So we'll choose the first one. And then we have one score. So this is our reference. So then we are going to iterate, right? So basically for C, so I can use a dummy index. So for dummy index in range, so k up to the length of zipped, or you can see nums1 or nums2 length. That's the same thing. And then we get the current N2 and N1, that is zipped and G, right? Then we want to check if the current minimal is N2, what's the maximum score we can have, right? So notice that the current total is given, right? So it's a running state. It's the previous key value sum in nums1. And then we want, so now that we want to choose the current number N1 and N2. So N2 is the current minimal, right? And then we need to include this N1 in the key elements. In other words, we need to pop one from the previous chosen one. This is easy, right? So we get the previous smallest from chosen, right? So let me use smallest N1 in the previous. This is basically heap pop from each, right? So we have this one, and then what we are going to do? So we are going to heap push. So we are going to add this to N1. Just this heap will always maintain the current chosen key numbers. So now we have chosen A1, so N1. So we want to add it. So the current total is going to be total minus the smallest N1, right? Because we want to pop the smallest chosen element in the previous key values. And then we are going to increment by the current one number, right? So that we are going to choose. And then what we are going to do is to make a comparison. Score equals max, the score plus the current score. The current score will be the total times N2. N2 is the current smallest, and this is the maximum possible key sum. And then what we are going to do is to return the final state of this score. So this is the code corresponding to the above digest. So before we make any comments, let's first do a check. So here, let's see. Oh yeah, I think we need to use G. So here we have this one. We retrieve this. So rather than actually we can directly use an element iteration, but this seems convenient. Now let's do a check. Let me check that. So we have here. So it's nums2, nums1. So we sort according to nums2. Now let's check. So we get number example 1 passed. So now let's look at the generic case. Yeah, it passes all the cases. With that said, basically that's about it for this specific problem. So here I would suggest that you first look at this code, and then look at this digest again to gain a better understanding of the logic. So once we digest the logic or fix the idea, so we can design code like this. So this provides one solution format. You can for sure fine-tune this code to make it shorter. Also, you can sort from small to large, and then adjust the code here. Still, you are going to have a working solution. So with that said, I think that's about it for this video. Thank you.